Good day everyone. Today, we are from Group 1. We will be presenting on sample contamination. This presentation will explain what sample contamination is, how it can occur during food handling and storage, and why it is important to control contamination to ensure accurate and reliable analysis. First of all, I would like to read our scenario, which is a food sample analysis shows unexpected high level of contaminants. Upon investigation, it is found that the samples were not stored properly, leading to contamination. To give better understanding, we illustrate the scenario in a visual way. Whether it is cooked or raw food, when it is not stored properly, they will be contaminated. So, this slide illustrates a scenario of sample contamination caused by improper storage. Initially, the food sample is collected in good condition. However, when it is not stored properly, such as being exposed to unsuitable temperature and unhygienic condition, microorganisms can grow. As a result, the food sample becomes contaminated, which may affect the accuracy of subsequent analysis. So, what is sample contamination in food context? When foreign substances are unintentionally introduced into a food sample, altering its original composition. This contamination may arise during various stages, including sample collection, transportation, storage, preparation, or analysis. Improper storage such as wrong temperature, air or moisture exposure, and poor lab hygiene can cause chemical degradation, microbial growth, and cross-contamination, leading to falsely high contaminant levels during analysis.
Next, why should we do food analysis? Food analysis is essential for many reasons that directly impact safety, quality, and also consumer trust. First, ensuring food safety. Food analysis helps detect harmful substances before products reach consumers, reducing the risk of foodborne diseases. Second, supporting quality control. By analyzing food at different stages of production, we can maintain consistency in taste, texture, and also overall quality. Third, ensuring compliance with food regulations and standards. Food analysis confirms that products meet legal and regulatory requirements set by authorities. Fourth, providing accurate analytical results. Reliable testing ensures correct data for decision-making in food production and research. Fifth, helping identify chemical contaminants. It also allows us to detect pesticides, heavy metals, or additives that may be harmful if present in excess. Sixth, detecting microbial hazards. Food analysis identifies bacteria and pathogens that can cause foodborne illness. Seventh, determining food composition and nutritional characteristics. It helps measure nutrients like proteins, fats, carbohydrates, and also vitamins. And finally, protecting consumer health and safety. All these processes work together to ensure the food we eat is safe, nutritious, and also trustworthy.
Next, I will explain how to avoid food contamination during food sample storage. Food contamination can occur in physical, chemical, or biological forms. Therefore, proper storage methods are important to maintain food safety, quality, and accurate test results. First, food samples must be stored at the right temperature. Different types of food require different storage temperatures. For example, dairy products should be stored in a refrigerator at 2 degrees Celsius to 4 degrees Celsius, while meats, seafoods, and poultry should be stored at 1 degree Celsius to 3 degrees Celsius. If the food sample needs long-term storage, freezing at -18 degrees Celsius is recommended to prevent bacterial growth. Second, food samples must be stored in suitable containers. The containers should be clean and sterile to avoid contamination. Airtight and non-leaking containers are important because they prevent air from entering and reduce bacterial growth. High-quality plastic containers such as polypropylene and polyethylene are suitable because they are chemically inert. Some food samples are also require containers with light protection to prevent the breakdown of enzymes or vitamins. Third, labeling the food samples is very important. Each container should be clearly labeled according to the type of food sample. Proper labeling helps prevent mix-ups and cross-contamination, especially when multiple food samples are stored together. Lastly, food sample should be divided into smaller portions. This is because only a small amount of sample is needed for testing. Dividing the food into smaller portions also prevents repeated thawing and refreezing, which can cause rapid growth of microorganisms and bacteria.
I'm rice. If you soak me and put me in the fridge, I'll become poisonous material that can poison you. Get me out of the fridge quickly. I'm garlic. The fridge cold turns me into a toxic substance that attacks the liver. Get me out of the fridge quickly and don't store me in it. And I'm ginger. The fridge cold turns my oils into substances that attack the stomach and cause you severe pain. Get me out of the fridge. And I'm the onion. The fridge cold makes me oxidize quickly and grow bacteria that cause acute poisoning. Get me out of the fridge.
So the first procedure to prevent the sample food from contamination, which is establishment and implementation of standard operating procedure, which is called the SOP. So how does SOP works? SOP can ensure the consistent and accurate laboratory practice, which is cover all stages of sample handling. SOP also reduce human error through the clear instruction, which is like specify the proper instruction, storage and handling. SOP also help prevent the contamination and also ensure the reliability. So the second procedure to prevent the contamination, which is personal training and competency assessment. Personal training and also competency assessment also ensure the staff are properly trained in sample handling and hygiene, and also combine the theoretical knowledge with practical training to enhance the procedure to prevent the contamination, and also conduct regularly competency assessment and identify skill gaps and improve performance. So the third procedure, which is implementation of GLP. GLP stands for Good Laboratory Practice. How does it work? It promotes the cleanliness, organization, and consistency. GLP also ensures the regular cleaning and proper sanitation work areas, and also it maintains clean, well-stored equipment and also glassware. Implementation of Good Laboratory Practice or GLP also separate sample preparation, storage, and waste area. And also it ensures proper documentation of traceability and quality control.
Number 4. Controlling environmental conditions in order to prevent sample contamination. Maintaining proper temperature, humidity, and air quality is essential because environmental factors directly affect the stability and quality of sample. For example, high temperature or excessive moisture can accelerate chemical reaction and encourage the growth of microorganisms, which may alter the original properties of the sample. In addition, refrigerator and freezer must be monitored and calibrated regularly. This ensures that samples are stored at the correct temperature at all times and reduce the risk of temperature fluctuation that could lead to sample damage or inaccurate results. Overall, by controlling these environmental conditions, we can effectively prevent microbial growth and sample degradation. This helps to maintain sample integrity and ensure that the data obtained from laboratory analysis is reliable, accurate, and scientifically valid. Equipment maintenance and calibration in the laboratory. Proper maintenance of laboratory equipment is very important to ensure safety, accuracy, and reliable experimental results. Therefore, all laboratory equipment should be regularly inspected and cleaned to prevent contamination and damage. In addition, instruments must be calibrated according to the manufacturer's specification and schedule interval. This helps to ensure that all measurements taken are accurate and consistent over time. If any equipment malfunction is detected, it should be corrected immediately to avoid errors, accidents, or invalid results during experiment. Finally, accurate maintenance and calibration records must be maintained. These records are important for quality control, traceability, and to ensure compliance with laboratory standards and procedure. For the last one, proper sample handling and storage in the laboratory. Samples should only be handled by trained and authorized personnel to reduce the risk of contamination errors and safety hazards. It is also important to use clean, airtight, and appropriate containers to protect the samples from external contamination and to maintain their integrity. All samples must be clearly labeled with the required information, such as sample name, date, and type, to avoid confusion or mix-ups during analysis. Lastly, samples should be stored according to their types, hazard level, and analysis requirement. Proper storage ensures that samples remain stable and suitable for accurate and reliable laboratory results.
Next, we go to how laboratory handles sample contamination. The first step is to identify and confirm whether the contamination has actually occurred. Unexpected or abnormal results are verified by reviewing analytical data and calibration records. Instrument performance is checked to rule out technical issues. The laboratory also reviews the sample handling and storage history to identify possible mistakes. The analysis is repeated using the same or a new sample aliquot. This is to ensure that the contamination is real and not caused by analytical or instrumental error. And then, after that, once contamination is confirmed, the affected samples are immediately isolated from other samples. They are being clearly labeled as contaminated and stored in a specific area. This will help prevent cross-contamination during further handling or analysis. The third step is documentation and reporting. All contamination incidents must be properly documented for traceability. Records include sample identification, analysis date, storage conditions, and personnel involved. The incident is then reported to the laboratory supervisor for further action. And then the fourth step is disposal or recollection of samples. Contaminated samples are disposed according to laboratory waste disposal procedures. If accurate analysis is still required, new samples are recollected. This ensures that the results obtained are reliable and representative of the actual conditions. And then after that, a root cause analysis is carried out to determine how the contamination occurred. The laboratory will examine storage conditions, packaging, and sample handling practices. This will identify the source of contamination to help prevent similar incidents from happening in the future. Corrective and preventive actions are then implemented. This may include improving sample storage conditions, updating standard operating procedures (SOPs), providing additional staff training, and enhancing overall sample handling quality. This action will help improve laboratory performance and reduce future contamination risks. And then finally, review and communication. Laboratory management reviews the contamination incident and the corrective actions taken. These findings are shared with all laboratory staff to raise awareness. This will help prevent poor sample handling and storage practices in the future. In conclusion, food sample contamination can occur at any stage of analysis, especially during sample storage and handling. Well-trained personnel and strict SOPs help reduce human error and contamination risks. Proper storage conditions and good laboratory practices are essential to maintain sample integrity throughout the analysis. Finally, effective control and timely response to contamination ensure accurate analytical results and support overall food safety.